The James Webb Space Telescope, or JWST, is the most powerful telescope ever launched into space. This marvel of engineering is designed to answer some of the most profound questions about our universe. With its advanced technology, JWST is set to revolutionize our understanding of the cosmos. It allows us to peer deeper into the universe than ever before. By capturing light from the earliest moments after the Big Bang, JWST provides a glimpse into the formation of the first galaxies. This unprecedented capability helps scientists study the evolution of the universe over billions of years. One of the most exciting areas of research for JWST is the study of how stars and planets are formed. By observing star-forming regions or cosmic nurseries, JWST helps us understand the processes that lead to the birth of stars and planetary systems. This knowledge is crucial for understanding our own solar system's origins. JWST can see infrared light, which is invisible to the human eye. This capability allows it to observe objects and phenomena that are otherwise hidden. Infrared light is essential for studying the cold and distant parts of the universe where new stars and planets are forming. Infrared light can penetrate through clouds of gas and dust that obscure our view of star-forming regions. This means JWST can reveal hidden structures and processes within these clouds, providing a clearer picture of how stars and planets come into being. This allows us to see the very early stages of star and planet formation. By studying these early stages, scientists can learn about the initial conditions and processes that lead to the development of stars and planetary systems. This information is vital for understanding the diversity of planetary systems in our galaxy. Recently, JWST has captured stunning images of a Herbig-Haro object called HH30. These objects are formed when jets of gas ejected by young stars collide with surrounding gas and dust, creating bright and dynamic structures. The detailed images of HH30 provide valuable insights into the interactions between young stars and their environments. These images are providing us with new insights into the processes that give rise to stars and planets. By studying these interactions, scientists can better understand the complex dynamics that shape the formation and evolution of celestial bodies. The discoveries made by JWST are paving the way for a new era of astronomical research, offering a deeper understanding of our place in the universe. Stars and planets are born in giant clouds of gas and dust called molecular clouds. These vast regions of space are the cradles of stellar and planetary formation, where the raw materials of the universe come together under the force of gravity to create new celestial bodies. These clouds are some of the coldest and densest places in the universe. Temperatures can drop to just a few degrees above absolute zero, and the density of the gas and dust is so high that it can block out light from stars behind them, creating dark, opaque regions in the sky. One such cloud, the Taurus molecular cloud, lies about 450 light-years from Earth. This cloud is part of the Taurus constellation, and is one of the most studied star-forming regions in the sky, due to its relative proximity and the wealth of young stars it contains. It is a hotbed of star formation. Within this cloud, countless new stars are being born, each one igniting as nuclear fusion begins in their cores, lighting up the surrounding gas and dust with their newfound energy. Nestled within this cosmic nursery is HH30, a young star surrounded by a swirling disk of gas and dust. This star is still in the early stages of its life, and the material around it is gradually coalescing to form planets, moons, and other celestial bodies. This disk, known as a protostar disk, is where planets will eventually form. Over millions of years, the particles within this disk will collide and stick together, gradually building up into larger and larger bodies, until they become planets. HH30 provides us with a glimpse into the chaotic yet awe-inspiring processes that unfolded billions of years ago in our own solar system. By studying this young star and its surroundings, astronomers can learn more about how our own sun and planets came into being. Studying HH30 helps us understand the origins of our cosmic neighborhood. By observing the formation of stars and planets in real time, we can piece together the history of our own solar system and gain insights into the processes that have shaped the universe as we know it. Herbig-Haro, or HH, objects are bright nebulous regions surrounding newborn stars. They are created when jets of gas are ejected from these young stars at incredibly high speeds. These jets collide with the surrounding gas and dust, creating shock waves that heat the material and cause it to glow. HH objects are spectacular displays of the raw power of star formation. They provide us with important clues about how young stars interact with their surroundings. By studying HH objects, astronomers can learn more about the processes that drive star formation and the impact these stellar outbursts have on the surrounding environment. To fully understand the complexities of star and planet formation, astronomers rely on a multi-wavelength approach. This involves observing celestial objects across different wavelengths of light, each revealing unique information. JWST's infrared capabilities are complemented by observations from other telescopes, such as the Atacama Large Millimeter Submillimeter Array, or ALMA, and the Hubble Space Telescope. ALMA is particularly adept at studying the cold gas and dust in protostellar disks. It can detect the faint radio waves emitted by molecules within these disks, providing insights into their chemical composition and structure. Hubble, with its sharp vision in visible and ultraviolet light, offers complementary views of the outflowing jets and the surrounding nebulae. The dance of dust, from grains to planets. Within the protostellar disk surrounding HH30, a delicate dance is taking place. Microscopic dust grains composed of elements like carbon, silicon, and oxygen are constantly colliding and sticking together. Over millions of years, these tiny grains coalesce into larger and larger clumps. This process, known as accretion, is the first step in the formation of planets. As these clumps grow, their gravitational pull increases, attracting more dust and gas from the surrounding disk. The detailed images from JWST allow us to study this process in unprecedented detail. Shaping worlds: the role of starlight, magnetism, and temperature. The formation of planets is not solely driven by gravity. While gravity is a fundamental force that pulls matter together, it is just one piece of a much larger puzzle. The intricate dance of cosmic forces that shape planetary systems involves a symphony of elements working in harmony. Starlight, magnetic fields, and temperature gradients within the protostellar disk all play crucial roles in shaping these nascent worlds. Starlight provides the energy that drives many of the processes within the disk, while magnetic fields can direct the flow of charged particles, influencing the distribution of matter. Temperature gradients, on the other hand, create zones where different materials can condense or evaporate, adding to the complexity of planet formation. The intense radiation from the central star can heat up the inner regions of the disk, causing volatile materials like water ice to evaporate. This process not only affects the composition of the disk, but also its structure. As the inner regions become hotter, they can drive winds that push material outward, creating a dynamic environment where planets are born. This creates a gradient in the disk's composition, with rocky planets forming closer to the star, and gas giants forming in the colder outer regions. The inner, hotter regions are rich in metals and silicates, which can form solid, rocky planets. In contrast, the outer, colder regions are abundant in ices and gases, leading to the formation of gas giants with thick atmospheres. Magnetic fields generated by the rotating disk and the central star can influence the dynamics of the gas and dust, channeling material onto the growing planets. These magnetic fields can create regions of turbulence and stability, affecting how and where planets form. They can also help to funnel material onto the surfaces of young planets, contributing to their growth and development. The interplay of these forces creates a rich tapestry of processes that ultimately lead to the formation of diverse planetary systems. Hubble's legacy: a cosmic collaboration. While JWST offers unprecedented views of the universe, it builds upon the legacy of its predecessor, the Hubble Space Telescope. Hubble, launched in 1990, revolutionized our understanding of the cosmos. Hubble's observations of HH30, though less detailed than JWST's, provided early hints of the complex structure of the protostellar disk and the presence of outflowing jets. These observations paved the way for JWST's more detailed investigations. The two telescopes, working in tandem, have significantly advanced our understanding of star and planet formation. The chemistry of creation ingredients for life? The protostellar disk around HH30 is not only a breeding ground for planets, but also a chemical factory. Within this swirling cauldron of gas and dust, complex organic molecules, the building blocks of life as we know it, are being forged. JWST's instruments are capable of detecting the faint signatures of these molecules, providing clues about the chemical conditions present during the formation of planetary systems. Understanding the chemical makeup of protostellar disks is crucial for assessing the potential for life to arise on other worlds.